because basically when you join for food industry, okay, even during my working time in private industry also, we need to measure viscosity. Okay, because viscosity, it does not only rely for those companies ataupun research lab that are producing liquid product. Okay, it can be those who are dealing with solid materials, because probably for your company, I mean the company that you are going to join later, uh, one of the apa tu ingredient that you receive, you need to measure the viscosity in order for you to maintain the consistency of the raw material as well as some of your product. Okay, because some of your product, for example, if let's say you are dealing with cream, so you need to make sure that the cream your company producing, I mean the production people producing, are consistent from batch to batch, from day to day production. All right. And then in terms of determination of viscosity, it will be vary depending on the industry that you join. Okay. For example, if let's say you are joining with apa tu milk industry, ataupun those that are conducting with beverages, producing beverages, so you are going to use a common viscometer that is known as a Brookfield viscometer. Okay, that one is viscometer is to measure viscosity. Okay, but then if let's say you go for the company, you join company that is producing spread. Okay, for example, you have the kaya spread, or you have those apa tu jam, right? And maybe heavy syrup. Those viscometer will be different. Okay, that one will be require some different type of viscometer that I will show you later in your lecture notes. Okay, because that one we need to make sure that the spreadability as well as the viscosity of that particular product is suitable for the purposes of that particular product. Okay. For example, when we talk about spread, spread tu macam contohnya you have the apa tu margarine spread. Okay, margarine spread, of course you need to measure the viscosity. We do not want it to be too thick, too viscous, or too liquid. Okay, if it is too viscous, then it is not able to be have an even spread on the bread or any material. If let's say it is too thin, maksudnya terlalu cair, too liquefied, that is not a good consistency as well. So depends on the company that you join later. The use of viscometer will be differ from one product to another product. Okay, so the overview for this particular chapter, viscosity is a principal parameter where this one it measure the flow of the fluid. Okay, the flow of the fluid, this one it involved with the liquid, semi-solid, even gels, okay, and gases, and even some solids are being measured as well. Okay, so anyone who is involved with flow characterization or development of the fluid. Okay, remember when we talk about fluid, fluid bukannya bermaksud is only meant for liquid. Fluid, it can goes for the liquid, for gases, as well as for those solid ataupun semi-solid that behave like liquid. Okay, contohnya macam we have flour. Tapi of course lah, flour kita tak measure viscosity. But for example, flour, when we pour flour from one container to another container, the flow of the flour is almost similar like the flow of water. So, you know, that's why some flour powdered material also belongs to the category of fluid. Okay, this one I'm talking about fluid, not viscosity. All right. So whenever you are dealing with something that relating to fluid flow, okay, fluid flow, liquid, semi-solid, gas, then you need to have the knowledge for the use of for the measurement of viscosity as well as rheology. Okay, basically viscosity, rheology, they are different. Right, viscosity is to measure whether that particular product is viscous or non-viscous. Okay, and then but then for rheology, this one is the study for the fluid properties. Okay, fluid properties involving with the molecular size, involving with the fluid flow, involving with the viscosity as well. Tapi macam I bagi tahu tadi, when we talk about viscosity, viscometer is only measuring about viscosity of the product. Okay, hope you're clear between viscosity and rheology. Alright, so now many manufacturers, they are regarding this particular viscometer as one part of a critical part to be measured to ensure that their product is consistent. Okay, because we do not want to produce, for example, kaya spread. We do not want to produce kaya spread. Last week it is very viscous. This week it is a very liquefy. The following week it is according to the specification that we want. So there is a no consistency. Kalau you all pernah beli contoh this one I am not downgrading companies, other companies, no. But this one just for your case study ataupun so that you are aware. If you purchase some of the tomato ketchup or chili sauce that is being produced by SME, contoh that you can purchase during the expo ke exhibition ke, you will notice that sometimes when you buy the product, I mean the same product, last month when you buy, the consistency is as per normal. The following month when you buy the same product, it is very liquefied. It is a very, I mean, liquid. It's thin. It is not viscous. So there is a lack of consistency for that particular companies. Alright, but then when we talk about when you join later for big industries or those industries that is really concerning about their quality of their product, so this measurement, the viscosity measurement, is one part of that is critical for them to measure in order to make sure that the consistency of the product. Okay, so the viscosity measurement are often will be the quickest, accurate and reliable way to analyze some of the most important factor that is affecting for the product performance. Okay, and then we have this rheology relationship. A rheological relationship help us to understand the fluid we are working with so that we can either know that they are behaving or forced to behave according to our needs. Okay, rheology, macam I mentioned tadi, is about fluid flow properties. Viscometer, okay, rheology tu kita panggil alat dia rheometer lah. Viscometer is measuring the viscosity of the liquid. So when you join food industry later, and you want to, I mean your company want to develop new product, so you will come out with your own specification or range for the specification of the viscosity for that particular product. Okay, and then of course when you want to measure the viscosity of the product, it will depends on several parameters that I will explain later. Right, so there are many different techniques for measuring viscosity, and this one it depends on the materials as well as the finished product. Okay, contohnya macam ni apa ni, this one. Okay, nampak tak gambar yang sebelah kanan ni? Okay, this one is when you are going to measure for those that is require the product to be able to spread. Okay, contohnya macam we have those jams ataupun probably some of the chili sauce. And then thick materials, okay, ataupun contohnya macam you have those canned tomato tomato sauce ataupun yang pasta, tomato yang pasta punya sauce tu kan. So those they are going to use this one. Okay, this one is known as consistometer. Ya ke? I think so. Okay, so this one, what happened is that your product will be poured in this particular area. Okay, and then after that you will lift up this particular gate. Okay, dia ada gate yang warna grey ni, you will lift up the gate and this particular product it will start to flow. Okay, dia akan flow dekat sini and you will measure what is the length of the flow for that particular liquid. If it is too thin, dia cair sangat, so of course dia akan pergi jauh. Okay, but then if it's too thick, the length will be shorter. So it really depends on the product that your company is producing. So the selection of the right viscometer from the scores of instrument available is to meet the need of application, and this one really depending on the product. So we have several instruments that is available to measure the viscosity of the product. So for example, we have Boswick consistometer, whereby this one we count the seconds of the liquid to drain. We have the Ford cups as well as line spread test. This particular one is known as line spread test. Okay, we have one of your seniors that went to, she did her internship in one of the governmental agency, if I'm not mistaken. They are producing kaya spread as well as jams. So she has the opportunity to use this kind of viscometer. Okay, um, some of them, I mean, they said it is a very old school style, but it is not a matter of old school or a new technology. No, this one is a matter of the usage of that particular viscometer according to the product itself. Okay, and then we have another one that is a very widely used in industry, that is known as Brookfield viscometer. Okay, Brookfield ni sebenarnya brand lah, is a brand of the viscometer, whereby majority of the institution as well as organization, they are using Brookfield viscometer. For this particular Brookfield viscometer, it is very simple. You have several spindle. Okay, nanti I tunjuk dekat you all what is a spindle. You have several spindle, and then you need to select which spindle is the best to suit your product that you are going to work with. And then after that, you immerse that particular spindle into your product and you just press start. After some time, it will give you reading, constant reading. Then you will take that reading and you will do some measurement, okay, some calculation in order for you to determine the viscosity of that particular product. And then of course, there are some other types of viscometer. This one is not Brookfield lah, other brands. Okay, other brands, they are going to give you immediate reading. Immediate reading, whereby when you submerge the spindle into your sample, okay, then you start to rotate. Once the reading is stable ataupun consistent, then you will take that particular reading. That reading is your viscosity, the viscosity of that particular product. Okay, kalau if so happen that you have the chance to go to Shah Alam later, Shah Alam, they have this particular old school type of Brookfield viscometer. Kalau old school viscometer tu, you nampak dekat bawah gambar sebelah kanan ni, okay, this one, they have this particular card that you need to do some simple calculation. Okay, the reading given by the Brookfield viscometer on the display, and then you need to do some calculation, a very simple calculation. But then of course, when you go to other industries, it is not necessary for them to use Brookfield viscometer. They can use their own preference of viscometer. And for example, when I'm working, the lab that I'm working with, okay, inside the lab that I'm working with, we are having this digital viscometer, whereby when I submerge the spindle, okay, spindle, this is spindle. Okay, nampak spindle ni dia macam, you have several types of mixer kan, to mix your product, for example. So sama jugalah macam spindle ni. Spindle, it depends on the characteristics of the product. So when I submerge the spindle, and then press start. So when the reading is becoming consistent, then I will take that particular reading. But of course, when you measure viscosity, okay, this one is another part. When you measure viscosity, it should be at the specific temperature. Okay, because different temperature will give you different viscosity. Okay, this one is important because some of the liquid, they are temperature dependent. Some of the liquid, some of the fluid, they are temperature dependent as well as they are time dependent. So of course, when you're measuring viscosity, it is depending on that particular product that you are working with. All right. So how the viscometer looks like. Okay, so we have this particular spindle that you immerse in your in your sample. Tak kisahlah spindle dalam water ke or tomato ketchup ke. Okay, and then some of the most of the viscometer, they are equipped with temperature probe. Okay, temperature probe is for us to know what is the internal temperature of our product that we are going to measure. Okay, and normal temperature that we are going to work with when we measure viscosity is at 25 degrees Celsius. Okay, 25 degrees Celsius is regarded as room temperature. You jangan ambil kata macam, oh dekat Malaysia kita tak sampai lah 25 degrees Celsius. No, this one is internationally known. 25 degrees Celsius basically is regarded as room temperature. Okay. So if let's say your product is too cold, then you need to increase the temperature to 25 degrees Celsius. If your product is too hot, then you need to reduce the temperature so that it goes to 25 degrees Celsius. So when you are measuring viscosity, it must be fixed at a certain set of temperature depending on which temperature that you are working with. But normally it will be 25 degrees Celsius. Okay, so this particular spindle ni nanti dia akan rotate. It will rotate and the speed of the rotation also depending on your product. Okay, so when you join the industry later, of course you need to do some R&D, okay, some research and development. You need to do some testing. What will be the speed that is considered as appropriate? What will be spindle type that you are going to work with? Okay, so nampak dekat sebelah kanan you ni, atas ni, we have several spindle, and each spindle they have different thickness, different diameter. Okay, so in order for you to measure the viscosity of the product, depends on the type of that particular spindle as well as the the viscosity of your fluid. Okay, this one is additional information lah, if I'm not mistaken, because this particular slide is being prepared by Eddie. Eddie is from University of Queensland. So this one to show you that this is one of the example of the conventional type of viscosity, viscometer to measure the viscosity of bitumen. Okay, tahu kan bitumen tu apa? Do you know what is bitumen? No idea? No one in the class?
Saya tak pernah dengar.
Huh?
Bukan yang buat jalan tar tu ke madam?
Betul. Bitumen tu yang buat jalan tar tu. Yang when you are processing the crude oil. Tahu kan crude oil, when we are processing the crude oil, so we have several, kan this one I think you all dah belajar masa chemistry ke physics, tak ingat masa sekolah menengah dulu. So you have several tier when you are, when the oil and gas company, they are processing the crude oil. So bitumen ni yang bawah sekali lah untuk nak buat jalan. Okay, so the consistency of the bitumen also need to be measured, this one by using pitch drop experiment. But then of course this one is not related to food products, so tak apa, just for your additional information saja. Alright, so why do we make a rheological measurement? This one is whereby we want to know the behavior as well as the consistency of that product. It shows very much useful behavior and predictive information for various products, which it can be obtained by performing a rheological measurement. As well as knowledge of effects of processing, formulation changes, as well as phenomenon. Okay, when we talk about rheology, we are going to use rheometer. When we talk about viscosity, we are using viscometer. So when we are using viscometer, you are only measuring viscosity. Okay, but of course, when you are measuring viscosity, when you have, contoh lah, katalah R&D department, they want to change the ingredient. So when they change the ingredient, of course, it will have some effect towards the viscosity of that particular product. So you need to measure the viscosity of that particular product. When there are some changes in terms of the temperature, there are some changes in the processing of that particular product. So it will give an effect towards the viscosity of that particular product. Okay. rheometer ni tak selalunya ada dekat dalam food industry because rheometer is very expensive unless that particular product, that particular company is heavily producing product that is requiring for the study of fluid flow properties. So that is necessary for that particular company to have rheometer. Because rheometer ni dia boleh measure viscosity sekali. Okay, termasuk viscosity. Tapi kalau untuk viscometer, it only can measure viscosity. Okay. So a frequent reason for measurement properties can be found in the area where raw materials should be consistent from batch to batch. Even for the finished product also, it needs to be consistent from batch to batch. Okay, contohnya if let's say the company is producing honey, for example, we have certain issues. If you look back for the honey issues, it is some of the companies, they do make some mixture of honey with sugar syrup in order to increase the volume and in order for them to sell. Because if you look logically, how can you produce so much of honey? When you go to the shelf, there's a lot of honey, and some of the prices are rather cheap. So that is one of the issue. But of course, when you look back into the food law and regulation, some of the honey product, they are allowed to have mixture of sugar syrup. So this one just contoh je lah. So if let's say the company is producing honey contoh so they want to make sure that the consistency of honey that they are producing is consistent from batch to batch, from day to day of the production. Okay, tapi yang ini kita tak boleh we cannot penalize for those yang jual honey, contoh macam dekat pasar tani ke whatever, because of course you will see that some of the day the honey is quite liquid. It's thin. Okay, the word thin ataupun thick bukan maksudnya nipis ataupun tebal no, it means that the liquid is a very light, dia sangat cair. Okay, thin tu maksudnya cair, thick maksudnya pekat. Okay, and some of the day the honey that they sold is thick. So those honey that is being sold by macam orang yang jual dekat pasar tani ke ataupun orang yang approach you dekat kedai makan ke, for example, those honey, that one I tak sure sama ada dia orang ada tambah sugar syrup ataupun tak, tapi the viscosity of that particular honey, it depends on the bees. Okay, lebah yang produce that particular honey. Okay, so of course when we because this one is a go back to the customer perception. Okay, so for viscosity, this one we have a classification of viscosity for the products. Okay, and this one is particularly for liquid. Right, so we have a thin liquid, we have thick liquid. The thin liquid contohnya macam water. Water, when you drop the water, there is no issue for the water to be dropped. Meaning that when you pour the cup filled with water, so the water will flow and it will drop. Okay, the same thing goes for milk, for thin oil. Okay, oil yang kita refer dekat sini, this one is relating to thin oil. But then when you go for some of the oil that is thick, okay, pekat, of course the the flow of that particular oil will be slower compared to thin oil. Okay, and then we have light syrup. Okay, light syrup, this one it goes back to the size of the molecular as well as the molecular distribution. Okay, then we have light syrup, heavy syrup, as well as chocolate syrup. So this particular, when we go for the viscosity of the liquid become more viscous, more thick, meaning you are require more time for that particular fluid to drop. Okay, but this one just a matter of length of drop. Okay, tapi we are not going to go into that. You are going to know what will be the classification of fluid. That is the most important thing that you need to know. Okay, so now what is the importance of making a rheological measurement? Okay, why do we want to study about fluid flow properties? Why do we want to measure the viscosity of the product? Okay, so basically flow behavior, this one is an indirect measure of the product consistency as well as quality, and it is a direct assessment of processability whereby it can be obtained, the result can be obtained immediately. For example, if let's say you are dealing with high viscous liquid, so it require more energy, more force to pump that particular liquid compared to if let's say you know about this particular rheology properties of that particular fluid. So the engineers, they are able to design the pumping system or to arrange the equipment that require in order for the production to to go through, right? So rheological is the most sensitive method for material characterization because flow behavior is responsive to properties such as molecular weight as well as molecular weight distribution. Okay, you all dah ambil subjek food engineering kan? So dalam, if you remember, dalam subjek food engineering, there is a one chapter that is dedicated for pumps. Do you remember about pumps? Ke tak ingat dah? Tak ada siapa yang
Belum
masuk?
masuk lagi. Belum masuk lagi, madam.
You all bukan part 5 ke?
Baru, tapi chapter tu tak sampai lagi.
Oh, bukan you all. Oh, sebab you all kohort baru kot. Sorry, I ingat you all dah ambil masa part 3.
Tak.
Because sorry.
Kita dah ambil part 5.
Oh, okay. Tak apa. So it's good. Later when you go into that particular chapter for pumps, you will notice that we have, in the industry, we have different types of pump, and different pump they have different application. Okay, so for example, if let's say you want to transfer for tomato ketchup, contoh tomato ketchup is a quite thick. Okay, it is a not thin liquid, it's quite thick. So in order for that particular tomato ketchup to be able to flow ataupun to be able to be pumped into the bottle, to be fill up into the bottle, you require pumps. So the size of the pumps, the force required by the pump, this one, it goes back to the rheological study of that particular food material. Okay, so nampak every time that we for food industry kan, it is interrelated with the designation of the equipment. So that's why you all kena belajar juga sikit-sikit pasal food engineering, pasal unit operation, because later on, okay, this one termasuk perempuan lelaki pun ada kan. When you join industry later, especially private industry, for ladies, you are expected to know the parts of certain machineries as well. Okay, so contohnya macam if let's say the fluid cannot be it cannot flow. So why it happen? Is it because of the pumping system ke, because of the piston ke, because of the something, certain parts of that particular equipment? Bila engineer give you feedback, when the engineer department give you feedback what went wrong during the production, you tak adalah macam apa tu piston pump tu apa, no. So that's why you need to know certain parts of the equipment. Okay, tak apalah, nanti yang tu baguslah juga, nanti you all belajar pasal pumps tu. We have single acting pump, dual acting pump, and etc. Okay, so why make rheological measurement? Alright, this one is for quality checking during production or for controlling a process. I remember when I was in my industry as well, one of our product, we are producing cream. Okay, cream tu untuk filling lah dekat dalam produk. When we producing cream, so that particular cream, we need to collect the sample, some of the sample of the cream, and then we will bring back that particular cream to the lab and we will measure the viscosity. Okay, because since the cream will be served as the filler for that particular product, we do not want that particular cream to be too thick or too thin. Because if it is too thick, then it will be difficult for our system, our equipment dekat dalam production to pump to fill up the cream into the product. If it is too thin, then nanti produk tu dia akan seeps into our product, which is not good. Alright. Okay, and then another one is to study the chemical, mechanical, thermal effects. Okay, thermal effects, this one, remember just now I've mentioned viscosity, measurement, as well as your food product. Sometimes it goes back to temperature dependent as well as time dependent. Okay, as well as the processing involved. So mechanical ni contohnya macam when you are doing mixing. Contoh when you are doing mixing cream, contoh if you are undermix, there will be some problem with the cream. When you overmix, then you will have some problem with the cream. So it must, that's why when we are dealing with products in industry, we need to have our set of specification, a range of standard and specification in order for us to know how to produce a consistent product from batch to batch. Okay. And then in terms of addition of additives, okay, this one depending what type of additives that you are that you are going to include into the product, and as well as the cost of curing reaction. Okay, the third one, why it is useful, is to predict and control a host of product properties and end use performance as well as material behavior. Okay, this one macam contoh yang I bagi tahu dekat you all tadi, if let's say the product is too thin, okay, cair sangat, and it serve as the filler for the product, so bahagian liquid tu, it will seeps into the product, and my end product will become soggy, which is not a good indicator. Alright. Okay, so viscosity. Viscosity is the measurement of the internal friction for the fluid. Friction tu contohnya we have liquid, okay, and then liquid tu it is being mixed. Okay, when it is start to be mixed, it has some friction, ada geseran dekat situ. Okay, so the friction will become apparent when a layer of fluid is made to move in relation to one and another layer. Okay, nanti yang ni I explain sekejap lagi. Okay, the greater the friction, the greater the amount of force required to cause this movement, which is known as shear. The greater the friction tu maksudnya if let's say your product, the viscosity of the fluid is thick, okay, viscous, so you require more force in order for the spindle to rotate. Okay. Sama juga macam when you are mixing batter untuk nak buat biskut raya ke apa ke, when it is a thin, kalau keadaan dia tak viscous, it is easy for you to mix. Okay, you don't need to have a high force to mix that particular mixture of product. But then when you start to include flour, you start to include those other solid material, it will become more viscous. So you require more force in order to mix that particular product. So it is almost, the mechanism is similar. The spindle tu, how it works, almost similar like what your mixer is doing. Ataupun when you mix your beverages, okay, so sama juga. You pakai sudu kan untuk nak mix your beverage tu. Contohnya macam you nak mix sugar and water, so you require mixing. Okay, that one is known as shear. Okay, so shearing, this one it occur whenever the fluid is physically moved or distributed. Contohnya pouring. Pouring tu contoh macam you pour tomato ketchup out from the bottle. Pouring So that one is shear as well. And then kita ada spreading. Okay, when you spread the jams on bread. Okay, that one is also known as shearing, spraying as well as mixing. Okay, so for highly viscous fluid, they are requiring more force in order for this particular fluid to move compared to less viscous material. Okay, if it is less viscous, meaning that you require less force. If it is too viscous, then you require more force. Okay, contoh dia macam ni each layer, tak tahu you all nampak I ke tak. Each product, they will have their own layer tau. Okay, and in between layer, they will have an empty spaces. Tapi of course, we cannot see this one by our naked eyes. So when, contoh when you want to rotate, okay, when you want to rotate the mixture, the liquid that is nearing your spindle. Contoh katalah you punya sudu tu kita panggil spindle lah. So the liquid that is nearing to your spindle, it will move according to the movement, to the direction of your spindle. Okay, contoh katalah you nak rotate clockwise. Okay, contoh clockwise. Okay, when you rotate clockwise, when the liquid, ini you all dah belajar inertia and momentum masa physics dulu. When the liquid is at rest, okay, you start the spinning of the spindle, maksudnya you rotate spindle tu, okay, some of the liquid, they will resist the movement. They will resist the direction of the movement for that particular spindle. So bila spindle tu moving clockwise, that particular liquid, because dia dekat at rest kan, so they try to move anti-clockwise. Okay, tapi the force required to make sure that the fluid is able to flow according to the direction of the spindle, maksudnya dia nak pergi ikut clockwise. Okay, that is the force required for that particular spindle to move the fluid, okay, according to the direction of the spindle. Direction of the spindle as well as the speed of the spindle. Okay, and liquid yang dekat dengan spindle tu, it will move at a faster rate. Tapi liquid yang jauh daripada spindle tu, they will resist the direction of the movement. Tapi slowly they will follow. Okay. When you continuously rotate that particular spindle, the fluid that is the farthest, maksudnya yang lebih jauh daripada spindle tu, they will start to follow the direction of the rotation. Okay. So that one is a shearing process. And the force required to to make that particular liquid to move according to the direction of the spindle, that one is known as shear stress. Nanti sekejap lagi kita I explain. So this one untuk yang chapter untuk slide ni, this one is what I have mentioned just now. Okay, how the layer of the fluid move in related to each other according to the force. Okay. So to express this particular viscosity, okay, viscosity, when you are regarding viscosity, you will encounter with two symbol. Okay, one is this one, eta. Okay, this one is known as eta. It will have in your next slide. Ataupun the most common symbol is being used is mu. Okay, nampak tak I tulis tu mu. Mu macam you all tulis yang untuk micro tu kan. So mu. This one is known as mu. When we symbolize for viscosity, it is either by using the symbol of eta ataupun mu. Tapi selalunya orang pakai mu lah, okay, untuk viscosity. Okay. Whenever the eta is constant for a given material, this one is known as viscosity. So the velocity gradient, which is dV dx. dV dx ni you tengok dekat sebelah sini. Okay, slide yang ni, dV dx is the measurement of the change in terms of the speed by which the intermediate layers will move with respect to each other. Okay, this one, it describes the shearing of the liquid, whereby it is known as shear rate. Okay, shear rate, whenever we encounter with the word rate is always associated with time. Time required for that particular liquid to be able to move according to the direction of the rotation. Okay, so this particular shear rate is being symbolized as S. Alright, and then the unit for this particular shear rate is per second. And F over A, this one force over area, this one is indicate force per unit area required to produce the shearing action. Okay, this one. Force over area, this one is the viscosity of that particular liquid. So this one is referred as shear stress, and they are being symbolized as F. Okay, shear rate tadi S, shear stress is F. Alright, so the unit of measurement is dyne per centimeter square. Okay, yang ini sama jugalah yang macam I explain just now. So the unit, okay, the unit for viscosity, okay, this one pun you akan dalam you all punya chapter 1 food engineering kan, you all kena belajar unit unit conversion kan. So one of the unit is viscosity. So viscosity, they are either being expressed, the unit is being expressed as Newton second per meter square, ataupun it is commonly used as Pascal second. Alright, so the CGS unit is dynes second per centimeter square, or also known as poise. Depends lah, when you join the industry later, depends what will be the unit that you are going to work with. Tapi commonly we are using Pascal second. Okay, so Pascal second is equal to 10 poises. Okay, one Pascal second is equal to 10 poises. Alright, so this one the same thing jugalah, the magnitude of apa tu force required to move a fluid material at a constant speed is given by force equals to eta, okay, coefficient of viscosity, AV divided by Y. Alright, so the SI unit for viscosity is Pascal second. The common unit for viscosity is poise. Okay, mana tahu nanti this one keluar dalam you all punya apa final exam for this particular chapter. What is the unit, what is the apa SI unit for viscosity. So SI unit for viscosity is known as Pascal second, and it also can go for Newton second per meter square. Newton second per meter square also is SI unit. This one you all pun dah belajar kan, SI unit and apa British unit. Okay, so the fundamental unit, okay. Another one, nanti contoh katalah keluar dalam soalan, what is the fundamental unit of viscosity? Fundamental unit is poise. Tapi SI unit kita guna Pascal second. Okay, a material requiring for shear stress of 1 dyne per centimeter square to produce a shear rate of 1 reciprocal second has a viscosity of 1 poise ataupun 100 centipoise. And you will also encounter with Pascal second ataupun millipascal second. Memang it is common to use either millipascal second ataupun Pascal second. These are units that is known as SI unit for apa tu Pascal second, Newton second per meter square. Okay, 1 Pascal second is equal to 10 poise, 1 millipascal second is equal to 1 centipoise. And for this particular viscosity, this one is being studied by Newton. Okay, so Newton, he assumed that all materials at a given temperature, viscosity, is independent of the rate. Maksudnya it is independent with the rotation. In other words, if let's say you increase the force, then the fluid will move faster according to the rate of the force that you given. But of course, this one is only partly right, because not all fluid are working as what this particular Newton has stated. Okay, so when we are measuring viscosity, we will have two types of fluid. Okay, one is known as Newtonian fluid and the other one is non-Newtonian fluid. Okay, so kita stop sekejap. Then we will proceed for this Newtonian liquid and non-Newtonian liquid sampai habis of this particular chapter. So we take a break sekejap, 5 minutes. Then we will continue. Okay, now it's 10:52. Around 11 lah kita start balik. Okay. Okay, kita sambung balik for Newtonian fluid and non-Newtonian fluid. Betul. Okay, so when you are measuring viscosity of the product, so you kena tahu for the properties ataupun the behavior of that particular fluid. Sama ada they are Newtonian fluid ataupun non-Newtonian fluid. Okay, kalau Newtonian fluid, it will follow what Newton has stated before. For example, when you increase the rotation, okay, when you increase the speed of the rotation, meaning that that particular liquid, the speed of the rotation of the fluid will follow according to the rotation of the spindle. Okay, yang itu adalah untuk Newtonian fluid. But it will not be the same case when we are measuring non-Newtonian fluid. Okay, non-Newtonian fluid ni contohnya macam mayonnaise, macam tomato ketchup. They are non-Newtonian fluid. Alright, so we will go one by one of this type of fluid. Okay, so the first one is Newtonian fluid. Newtonian fluid is represented by the graph below. Okay, kalau nak tengok the the simple graph of how fluid Newtonian fluid behave, you can look at the bottom graph in your slide. Okay, so we have graph A and we have B. Tengok yang kat bawah sebelah shear rate, and you can see that when we increase the rotation, nampak the line is straight line. Right? When you increase the force, of course, the movement of the fluid will follow according to the force that have been given. And this one for the graph B ni, this one related to the viscosity of the fluid. So for the viscosity of the fluid, you can see that it is consistent. Maksudnya there is no changes in terms of the viscosity for that particular liquid. They are constant. Okay, this one it shows, graph A shows that the relationship between shear stress and shear rate is a straight line. Okay, meaning that when you increase the shear rate, the movement of that particular fluid will follow accordingly. And then when we talk about graph B, this one it shows the fluid viscosity whereby it remains constant regardless of the speed of the rotation, regardless of the temperature, regardless of the time that you rotate that particular product, it will not cause any changes of the fluid. Okay, so contoh untuk Newtonian fluid ni adalah air, water, ataupun thin milk, susu, ataupun thin oil. Okay, contoh the best example will be water. Water, if let's say you boil water, it is at high temperature. Okay, air panas. And then you stir that particular water. Will there be any changes in terms of the viscosity for that particular water? Water alone, okay, kita tak ada tambah apa-apa ingredient for that particular water. When you increase the temperature and you you rotate, you kacau, you mix that particular water, will there be any changes in terms of viscosity? No.
No.
If okay, and then if let's say you cool down the water, okay, katakanlah around 25 degrees Celsius at room temperature, you increase the mixing process. Will there be any changes in terms of the viscosity of the water?
No.
Okay, tak ada juga kan, unless lah you masuk dalam freezer, yang tu different story lah. Jangan cakap, madam kalau kita turun lagi nanti masuk dalam freezer ke nanti dia jadi beku, tu that one is different. Okay, but then if let's say you cool down, you put into the chiller pun dalam peti sejuk, whereby you cool down the water before it becomes ice, if you stir pun, there will be no changes in terms of the viscosity. So water is a good example for Newtonian fluid, whereby regardless of the time, regardless of the temperature, regardless of your the rate, the speed of the rotation that you given, there will be no changes in terms of the viscosity for that particular liquid. Alright. Okay, so yang ini those equation, this one has been given in previous slide. I don't know why it keeps on repeating on the following slide. So this one pun sama. Okay, this slide ni sama juga macam yang your previous slide before. Okay, viscosity, it measure the force applied to overcome the resistance against rotation ataupun flow. This one I have explained to you just now. When we start to stir, basically the fluid, it will at first it will resist the movement according to your rotation direction. But of course, when you increase the force given, and this particular fluid, it will follow the direction of the rotation that has been given. Alright, so that one is the measurement of viscosity. Okay, so viscosity value, this one pun dah bagi tadi sama-sama. Okay, this one a matter of repetition of the previous slide. Alright, so this one example. Okay, example typical Newtonian fluid include water, okay, thin motor oils, and then I ada tambah dekat sini milk, susu pun sama. Thin milk, I'm talking about thin milk, susu biasa, bukannya heavy cream ke ataupun whipping cream ke, no. This one just milk. Alright, so the behavior of this particular fluid is known as Newtonian fluid. Okay, and this one I have given just now. Regardless of the temperature, regardless of the time, the viscosity of Newtonian fluid will remain constant. Okay, remain constant. Regardless of any spindle, type of spindle that you use. Remember just now kita ada different type of spindle. We have the thick spindle, and then we have a large diameter of spindle. We have small diameter of spindle. So regardless of any types of spindle also, it will not have any effect towards the viscosity of that particular liquid. So those type of liquid is known as Newtonian liquid. Okay, Newtonian fluid. And then when we talk about other types of liquid, we have different types of fluid. So majority of those of fluid, they fall into the category of non-Newtonian fluid. And for non-Newtonian fluid pula, we have several categories. Okay, so the major the big group of fluid, they are belong to the Newtonian fluid and non-Newtonian fluid. But then for non-Newtonian fluid, they will have their own categories. Okay, so for non-Newtonian fluid, this one kita ada pseudoplastic, we have plastic, we have dilatant, and then we have thixotropy as well as rheopaxy. Some of them, they are time dependent. Some of them, they are temperature dependent. And some of them, they are both temperature and time dependent. Okay, so that is non-Newtonian fluid. Non-Newtonian fluid meaning they don't behave like Newtonian fluid. Right. So non-Newtonian fluid is broadly defined as one for which the relationship of shear stress and shear rate is not constant. Okay, meaning that the viscosity is not constant. When you increase the shear rate, it can be become thickened. Dia akan jadi semakin pekat ataupun dia boleh jadi semakin cair. Depends on the type of that particular liquid. So in other words, when shear rate is varied, shear rate tu bila you tambah the speed of the rotation of the spindle, the shear stress doesn't vary in the same proportion or even necessarily in the same direction. Okay. Maksudnya, when we move the spindle, this one I have explained just now, when we move the spindle clockwise, so at first, the liquid, it will resist the direction of clockwise. Dia akan pergi kepada anti-clockwise. Tapi of course, when you continuously giving that particular rotation of the spindle, lama-lama nanti liquid tu pun akan ikut the movement. Right? So the force required, that is the measurement of the viscosity. So the viscosity of such fluid will therefore change as the shear rate is varied. Depends on the type of the non-Newtonian fluid. So the use of viscometer model, the dimension of sample container. Okay, sample container tu contohnya you nak letak your sample dalam beaker. Okay, so the volume of the beaker, the volume of your sample also is play a role in determining the viscosity of that particular product. Alright. Jadi bukannya boleh macam when you want to measure viscometer, when you want to measure viscosity, oh hari ni I nak pakai beaker 250 ml, I nak isi 100 milliliter of my liquid. The next day, oh I nak pakai beaker 100 ml, I isi 50 ml. Tak boleh boleh. It must be consistent in terms of the volume of the beaker ataupun the cup that you are using. Even the volume of the sample that you are putting into that particular beaker also must be consistent, so that your measurement is reliable. Okay, the value that is being given is reliable. So we have several factors that also affected the non-Newtonian fluid. Okay, contohnya viscometer model. For example, when you are talking about either Brookfield viscometer ataupun the spreadability viscometer, that one depends. Okay, dimension of sample container. Okay, filling level, the volume of the sample that you are putting into the beaker. Sample temperature, this one I have mentioned just now. Sample temperature is very important for you to monitor. Okay, and then the spindle, type of spindle, which type of spindle in terms of the the diameter of the spindle, the thickness of the spindle, those play a role in viscosity measurement, as well as the rotating speed. So rotating speed ni pun basically when you join industry later, we don't have a fixed law. What is the rotating speed required? What will be the viscosity range of this particular product? We don't have those kind of law. Tapi that when you join industry, your company will have their own set of standard and specification, the range of standard and specification for each type of product. Okay, so that particular standard and specification dalam kamu punya industri, itulah kamu punya regulation when you are going to perform viscosity measurement. Alright, and then the use of spindle protector. Okay, ada guna spindle protector ataupun tak, because when you are using spindle protector, basically you are going to have an effect towards the movement of the rotation for that particular fluid as well as the duration of the test. Duration tu maksudnya how long you perform that particular test. Spindle tu you spin, you rotate for how long? Seminit ke, 2 minit ke? After 2 minutes then only you will take the constant reading ataupun you need to wait until 5 minutes. Alright? It depends. But the most it is important for you to cater to take care in terms of the time as well, because the longer of time you require, it will have an effect towards the viscosity of that particular liquid as well as the temperature of that particular liquid. Okay, katakanlah kamu buat viscosity measurement in air conditioned room. Baguslah dalam air conditioned room whereby you can maintain the temperature. But if let's say the room is too cold, then it will affect towards the temperature of your product. If it is too hot, then it will affect towards the temperature of that particular fluid. Okay, so these are the factors that are having an effect when we are measuring non-Newtonian fluid. When you are measuring Newtonian fluid, you will not have any kind of this particular problem. But when you are measuring non-Newtonian fluid, so these are the factors that you need to consider in order for you to perform viscosity measurement. Okay, so just now I dah bagi tahu kan, sama ada you guna eta ataupun mu, okay, untuk symbolize as viscosity. Selalu kita pakai mu lah. Okay, at each specific rate of shear, the alignment may be different and more or less force may be required to maintain the motion. There are several types of non-Newtonian flow behavior, whereby it is characterized by the way of fluid changes in response to variation of shear rate. Okay, so this one we have we have 5 types of non-Newtonian fluid, and this one just for your general information sajalah. Classification 1, 2 dan 3, pseudoplastic, dilatant and plastic, they are non-time dependent. Maksudnya when you rotate your product, okay, it is not going to have a very huge effect towards the viscosity of your product. But then when we talk about thixotropy as well as rheopexy, they are time dependent. Time dependent meaning that the longer, the longer you rotate the spindle, it will have effect towards the viscosity of that particular product. Okay, and it may become irreversible. Okay, we will discuss this one later. Okay, so we go first with pseudoplastic. Pseudoplastic, this one is a type of fluid that will display a decreasing viscosity with an increasing shear rate. Okay, contohnya macam dalam graf dekat bawah ni. Alright, contohnya milk, this one will be thick milk, I guess. Alright, so contohnya liquid for non-Newtonian fluid whereby they have pseudoplastic characteristic. This one involving with the emulsion, ink ataupun jam. Alright, and this one is known as shear thinning. Okay, so what happened for pseudoplastic is whereby when you put your sample into a beaker, you look at your sample, it is a viscous. Okay, it is viscous. But then when you subject to rotation, your spindle start to rotate ataupun kamu start to mix. Okay, you start to mix pakai sudu ke apa ke. Contoh macam emulsion ni. Emulsion tu contohnya macam milk is emulsion as well, and then different types of emulsion. So when you spin, okay, at first you look at the fluid is like thick, viscous. But then when you start to rotate, okay, along the time, along with the rotation, it will start to become thinning. Dia jadi semakin cair. Tadi pekat, tadi viscous. So when you start to rotate the spindle, it will become less viscous. So less viscous, this particular characteristics of pseudoplastic, it is also known as shear thinning. Shear thinning tu maksudnya when you subject to shear stress, that particular product, it become thinning. Dia jadi semakin less viscous. So this particular graph, contoh I ambil graph B ni, graph B because this one it meant for the viscosity. Okay, so when you increase the shear stress and shear rate, so the viscosity of this particular product, it will goes down. Okay, dia akan jadi semakin cair. Alright, this one is pseudoplastic. Alright, then contoh dalam kamu punya lecture notes, we have this fresh soy milk. Okay, this particular graph you will get when you are performing rheological studies, rheometer, when you are having rheometer. Okay, because rheometer you will have this both values of viscosity as well as the shear rate. Okay, so you can see that the graph at first, this particular fresh soy milk, at first it is viscous, and then when it is subjected to high shear rate, the viscosity become lower. Sorry lah, jagged line pula. Okay, and then another category is dilatant. This one is non-Newtonian, dilatant. Okay, dilatant is whereby the product, when you increase the rotation, that particular product will become more thickened. Okay, dia akan jadi semakin pekat. Alright, contohnya macam custard ataupun if you have encounter nak buat, tahu tak kuih yang buah Melaka tu? Apa? Onde-onde Dia panggil onde-onde something. If you have the experience of doing that type of kuih, apa? Onde-onde kuih buah Melaka, I don't know. You can see that onde-onde You call it onde-onde? I don't know because my family will call it as buah. Lapar pula. Okay, so when you mix you pakai you pakai tepung jagung kan? Ke tepung beras?
Tepung beras.
Tepung beras.
Tepung beras. So when you mix tepung beras with water, at first it is thin. Dia cair. Tapi as you continue to stir, it will become thickened. Dia akan jadi semakin pekat. So that properties of mixture is known as dilatant. Lepas ni boleh lah sambil you buat kuih onde-onde tu, this one is the dilatant properties. Bagi tahu kat mak you. Alright, so when we talk about dilatant, meaning that the viscosity of the mixture, it increase, meaning that it become more viscous when you increase the shear rate of that particular spindle. Okay, so this particular dilatant characteristics is frequently observed in fluid containing high level of deflocculated solid, for example clay slurries ataupun candy compound. Candy compound ni sebenarnya I nak tunjuk dekat you all. Ada video dalam YouTube how they make this candy. Yang hard candy tu. If you notice hard candy, basically it start off with the mixture of those tepung lah. Cornstarch, rice starch as well as water, and then of course they will add sugar. And as they mix that particular mixture, it will start to become thickened. And selepas tu when you leave it, it will start to become hardened. So that is candy compound, as well as sand or water mixture. Tak apalah, you all boleh cari sendiri kot. Tengoklah how orang produce that candy compound. Ataupun if let's say you are staying in Klang Valley, nanti after the CMCO already lifted, you can go to, if I'm not mistaken, Wan Utama ataupun Sunway Pyramid, or a better excuse for you to go jalan-jalan. Tak apalah, this one just your general information je. You can go either to Wan Utama ataupun Sunway Pyramid. They have this one shop that is producing, that is selling this candy compound. They are doing the process of making this candy on site dekat dalam kedai tu sendiri. So you can see that they need to do some shearing. They all akan tarik that particular candy. They all akan sangkut that candy tu on a hook, dan lepas tu they all akan tarik the mixture. So the processing of tarik the mixture, that one is known as shearing as well lah. Okay, and as they shear, they performing the shear, then that particular candy compound will become thickened. Okay, so since tadi pseudoplastic is shear thinning kan, shear thinning meaning that when you increase the rotation, that particular liquid become thinning, dia jadi semakin less viscous. But when we talk about dilatant, when you increase the rotation ataupun you increase the mixing process, it will become more viscous. So when it become more viscous, meaning that it is known as shear thickening. Okay, the flow behavior is shear thickening. So kalau kamu refer, if you go to this particular graph dekat bahagian bawah ni, okay, it is in reverse with pseudoplastic. Okay, meaning that it start off with a less viscous liquid ataupun less viscous mixture, but then when you increase the shear stress, the shear rate, so the viscosity of the fluid will start to move up. Okay, it become more viscous. Okay, this one is apa ni? This one is the gambar yang ditambah. I pun tak sure. Okay. Alright, then we move on to plastic. Okay, plastic, this one is a commonly encountered type of fluid. Okay, this particular fluid, it behave as solid under static condition. Sepatutnya ada gambar dekat sini, hilang pula gambar tu. Tak apalah, nanti dalam you all punya slide tu ada gambar orang tu dia buka tomato ketchup and then suddenly the tomato ketchup burst out. Okay, contohnya this one we talk about tomato ketchup. Okay, if you go to overseas later, orang kat luar tak panggil tomato sauce, they call it as tomato ketchup. Okay, when we talk about tomato ketchup ataupun chili sauce, when it is placed undisturbed, okay, they can behave like a solid. When you want to pour this particular chili sauce ataupun tomato ketchup, you require to have additional force in order for that particular fluid to flow. Okay, and I am talking about when you are keeping, when this particular chili sauce ataupun tomato ketchup is being packed in glass bottle. Bukan yang squeezable bottle tu. Squeezable bottle tu, yang tu bukan, you tak boleh nak tengok how it behave. Okay, so kalau macam tomato ketchup tu, at first, when you open up the bottle tu, bila you baru lepas beli kan, when you open up the bottle, you require additional force. Kadang-kadang tak boleh keluar pun tomato ketchup tu. Then what you need to do? You need to tap the back of the bottle. You need to tap. When you are tapping the bottle, actually you are given force. And bila you tap pun, you need to tilt. Kamu kena sengitkan botol tu ke bawah. When you tilt and you give force, when you tap at the back, at the bottom of the bottle, you are giving the force, and you are forcing that particular fluid to flow downward. Okay, bila kamu tilt, katalah kamu tak tap, ini untuk yang kita baru beli bukan yang kamu dah pakai halfway, yang dah cair semua tu, tak. And another good example will be chili sauce, because chili sauce contohnya macam chili sauce that I bought is quite thick. So at first, walaupun kamu tilt, when you tilt the bottle, ini yang lepas kamu baru buka that newly bottle, when you tilt the bottle, that particular sauce ataupun tomato ketchup, it resist, dia tak nak turun ke bawah. Although kamu dah turun ke bawah, ada gravitational force turun ke bawah, this particular tomato ketchup ataupun chili sauce, what happen is that they resist the movement going downward. They are moving upward. Okay, so that's why what happen is that because they are behaving like solid and they resist the movement going downward. So in order for you to force, kamu nak paksa this particular fluid to flow out from the bottle, that's why you need to tap at the bottom of the bottle. And when you tap, you are giving additional force for that particular fluid to to move downward and flow out from the bottle. Alright. So that particular force, the amount of force is applied and it is known as yield value. Okay, the force that you are tapping ataupun kamu goncang-goncang botol tu, that one is a yield value. Okay, additional force that is being given. So tomato ketchup, ketchup ni dia punya spelling ni ada dua lah. Satu memang this is the spelling and another one is KETCHUP, ketchup. Okay, tomato ketchup ataupun chili sauce in Malaysia is a good example for this particular type of plastic characteristic. Okay, whereby the yield value tu the additional force will often make it refuse for the material to pour out from the bottle until the bottle is being shaken ataupun struck, whereby only then the tomato ketchup is allowed to flow out from the bottle freely. Okay, but then once the yield value has exceeded and flow begin, you will notice that the flow of the fluid is becoming ataupun dia display Newtonian flow. Maksudnya dia akan keluar undisturbed. Alright, so plastic it can go like Newtonian flow ataupun it can flow like pseudoplastic ataupun dilatant flow characteristics. Okay, and if you can see here untuk graph A ni, dalam graph A, kamu nampak tak dekat sini dalam graph tu ada there is no changes in terms of the viscosity for that particular product. And at this particular point, when the yield value has exceeded, then only this particular flow of the fluid will start to flow out from the bottle. Okay, and for the viscosity, initially it is thick, pekat. Okay, but then when it starts to exceed the yield value, then it can follow the characteristics of either pseudoplastic, Newtonian ataupun dilatant. Okay. Oh, ni gambar dia. Alright. And then we have thixotropic and rheopexy. Okay. Thixotropic and rheopexy, this one they are material that can be thin and thickened according to the time. Okay. So some fluid, they will display a change in viscosity with time under condition of constant shear rate. Maksudnya there is no changes in terms of shear rate, tapi you prolong the time of shearing. When you prolong the time of shearing, so the liquid, it can be thickening or it can be thinning. Alright, so two categories for thixotropy. Thixotropy ni dia follow macam pseudoplastic. Okay, as shown in the figure below, a thixotropic fluid, it will undergo a decrease in viscosity with time. Okay, time. Nampak thixotropy, rheopexy, they are time dependent. Pseudoplastic, dilatant, plastic, they are non-time dependent, but they are depending with the shearing rate. Okay. So this one, when it is when the fluid is having constant shearing, okay, so it will have a decrease in viscosity with time. This one is thixotropy. So contohnya we have tomato ketchup ataupun mayonnaise. This one when you are keep on stirring. And for rheopexy, this one is in the opposite of thixotropic, whereby when you are subjected to constant shearing but with prolonged time, the viscosity, okay, this one, the viscosity, it will start to increase according to the time. Okay, contohnya macam lubricants ataupun some paints. Okay, but then of course there will be occurrence of both thixotropy and rheopexy that are apa tu? They are going to encounter in combination. Maksudnya they are this particular fluid, they are behaving thixotropic and rheopexy in combination. And when they have this combination, this particular fluid is considered as irreversible, meaning that once you have reached certain viscosity of that particular liquid for over a period of time, it cannot be reversed to the original state of the fluid. Okay, so this one apa in combination of thixotropy and rheopexy, it only happen at certain shear rate, okay, constant shear rate, and the time element is extremely variable. Under condition of constant shear, some fluid will reach their final viscosity in a few seconds and others may take several days. So if you join to food industry later, it is very common for you to look at some of the product is being mixed for a period of time. Okay, sometimes it needs to be required for several hours because they want to reach the consistency ataupun the viscosity of that particular product. Okay, for rheopectic fluid, they are rarely encountered, but for thixotropy, it is a frequently encountered. Contohnya macam apa greases ataupun heavy printing inks as well as paints. Okay, so when subjected to varying rate of shear, thixotropic fluid, it will react as this particular graph. You can see that it start off with increasing of the viscosity, but then when it reach at certain point, okay, this one it will move down. Okay, it will move downward, but it will not go back to the original viscosity of the product. Okay, so a plot of shear stress versus shear rate was made as the shear rate was increased to a certain value, then immediately decreased to the starting point. Okay, so if you notice the up and down curve, they do not coincide, meaning that the viscosity of the original fluid will no longer be achieved after it has goes down to another process. Okay, and this particular apa ni changes here, this one is known as hysteresis loop. Okay, hysteresis loop, this one is caused by the decrease of fluid viscosity with increasing time of shearing. So this particular effect, it may or may not be reversible. And for some thixotropic fluid, if it is allowed to stand undisturbed for a while, it will get back to its initial viscosity, but some of them, they will not going to have the same viscosity as the initial product when it starts to become to mix. Alright, so these are the apa tu YouTube videos that you may watch, whereby this one is for you to check for the cornstarch and water how it behave. Okay, it become more apa tu viscous as you mix, and apa tu you can check on your own lah this particular YouTube videos. Okay, so alright, ini pun nanti you all akan belajar juga dalam chapter 7 for your food engineering. Okay, in chapter 7 for food engineering, we have several types, of course, several types of apa tu non-Newtonian fluid. Okay, whereby we have Bingham plastic, pseudo-plastic, Newtonian fluid. This one Newtonian lah, and then we have dilatant. Okay, so this one basically the explanation is similar what we have apa tu what you have been explained in previous slide. Okay. Alright. So this one this particular slide, this one is meant for the viscometer that we have in the lab, if I'm not mistaken, because I have not been in the lab for several years. I think this is the apa tu procedure of how you need to use the viscometer that you have in your lab. I mean in the lab in Kuala Pilah, in UiTM Kuala Pilah. Because in UiTM Kuala Pilah, we don't have Brookfield viscometer. We have viscometer that is made from Korea. Okay. So for viscometer unit that you have, okay, this one I bagi tahu dekat you. The viscometer unit that you have in your lab, you have two sets of viscometer, whereby one viscometer is to measure low viscosity of liquid, and another viscometer is to measure middle range of viscosity. And suppose you need to have another unit, suppose you need to have 3 units, but I do not know why you attempt only purchase 2 units, because the other unit is to measure for a very viscous liquid. Okay, so this is the setback of the viscometer that we have in our lab, whereby if you go to Shah Alam later, Shah Alam, they only have one viscometer that is Brookfield viscometer, because this particular Brookfield viscometer, it can handle the viscosity of the liquid from thin liquid until thick liquid with only one unit. Okay. So how to use this particular viscometer is whereby you need to insert the spindle. Okay, we have several types of spindle, and you need to make sure that you are using the correct spindle. And then you need to install the spindle to this particular shaft. Dia ada shaft dekat atas ni. Okay, yang bahagian spindle you yang ini tak tahulah you nampak ke tak yang I highlight warna merah ni. This is the spindle. Okay, yang bahagian tepi ni, this one is the protector of that particular spindle. Protector tu sebab apa? Sebab kita tak nak rosakkan the spindle tu. Spindle is quite expensive. Okay, and then check the correct spindle as well as identification number on the spindle. Choose the right spindle, whether it is a cylinder ataupun disc. Okay, and then they have this particular label. L1 is for low viscosity, L4 is for high viscosity of the measurement of liquid. So for L1, for example, if let's say the highest speed, it goes for 200 RPM for low viscosity. But then if let's say we go for a high viscosity of fluid, then you need to reduce the speed. It can goes down to 0.1 RPM. But I do not know whether we are doing this in the industry. If I'm not mistaken, we don't. But I do not know, because the industry that I joined, we only use a Brookfield viscometer. Okay, so what you need to do is you need to submerge the spindle into the sample, okay, until there is a point on the spindle tu. Dia ada macam ada point dekat sini where you should insert your sample up until to which length, right? And then put down the spindle guard for low viscosity. Kalau high viscosity kita tak letaklah spindle guard ni. Okay, and then choose the correct the correct reading for the viscosity. This one is being displayed here. Okay, on the display area ni, kamu boleh record the reading. Alright, and then you need to make sure that there is a no bubble inside that particular sample that you put in. Okay, because the presence of bubble, it will interfere with the reading of the viscometer. Okay, so for a summary, when we are measuring the viscosity of the product, basically it is meant to have a routine check for the quality, and it must be adhere to the specification of the product, to the sets of standard and specification of the product. Alright, when we measure the viscosity, this one is for R&D, this one is a production when we produce the product, as well as a QC, quality control checking, and consumption behavior. Alright, and then when we measure the viscosity, it is also goes back to the designing of the equipment. For example, the piping, the pumping required. Alright, and then when we talk about viscometer, normally it is analytical measurement, okay, by using the proper viscometer. Okay, then we have okay, and then another purpose of this one is the purpose why you are measuring the viscosity. One is whereby you want to achieve to the specification of the product. The other one is for the consistency of the product, whereby this one is the point of view from R&D, production, quality control, as well as the consumption. And then in terms of designing of the pipeline ataupun pumping system, and this particular viscosity is an analytical measurement, and it is meant for troubleshooting. If let's say you have a problem whereby your fluid do not want, it resists the flow. So what went wrong? Maybe the pumping force is not enough, is insufficient to pump that particular product, or the pipeline is too long. Jadi that's why pumping, the force of pumping tu is insufficient to move the liquid. So that can be some part of it why viscosity measurement is important in the industry. It's not only in food industry, in other industries as well. Okay, when we are talking about viscosity, even for cosmetic industry ataupun skincare industry, they are using viscosity measurement heavily, because if for the girls, for the ladies ataupun untuk lelaki lah, if let's say you are using liquid foaming bath ke ataupun liquid facial cleanser ke contoh, you need to make sure that the viscosity of the product is at its own specification. I mean, the company, they must produce the viscosity of the product at its own specification, so that that particular liquid is able to be pumped out from the product, or it is able to be poured out from the container. Okay, so jangan ingat viscosity measurement is only meant for food industry. It goes for other industries as well, and even other industries, they are using this viscosity measurement heavily as well. Okay, so when we measure viscosity, this one we are going to have a comprehensive knowledge about the fluid behavior. Contohnya for sugar coating ataupun chocolate coating, kan we have some product that is required for chocolate coating. So the chocolate coating tu pun you need to measure in terms of the viscosity of the chocolate coating, because it cannot be too thin, it cannot be too viscous. Kalau it is less viscous, it will not able to coat the product. If it is too viscous, the chocolate coating also cannot coat the product because dia akan jadi beku. It will frozen. Alright, so that is why viscosity is one of the important part of you to know in food industry for food quality control checking. Okay, so habis dah discard. Okay, habis dah chapter untuk viscosity. Yay! Okay, so do you have any question before we end the meeting? Only 40 of you are present here.
No, madam.
No, madam.
No, madam.
Tak ada. Oh, semua dah jam kepala kan?
Saya ada soalan.
Siapa yang ada soalan tu?
Saya madam.
Okay.
Dia nak tanya.
Cuk. Kejap. Kejap. Mana ni? You are presenting, stop presenting. Okay, apa dia?
Dia nak tanya.
Sekejap, kuat sikit.
Kita tak terdengar.
Kuat sikit. Dengar.
Ada nak tanya. Kita punya test bila, sebab saya ada orang hantar saya pagi tadi kata saya tak tahu daripada kelas kita.
Untuk test. Ingatkan nak tanya pasal chapter ni.
Tak.
Test kan saya ingatkan nak tanya pasal chapter. Test ni kan yang saya dah forward message dekat you all tu.
Oh, ada
So
aku tak pasal. Okay, dah. Terima kasih.
Okay, any more question? Tak apa, nanti kan kejap lagi I forward lagi sekali message tu. Panjang message saya tu. Tak tahu baca ke tak. Tak baca lah.
Barangkali saya terlupa, madam.
Okay, ada lagi soalan tak?
Madam.
Ya?
No questions.
No question. Okay, study untuk you all punya test. Esok test you all tau. It will be MCQ test. Saya tengok soalan ni senang je. InsyaAllah boleh jawab semua. Okay. Time given is only 1 hour and you have 40 question. InsyaAllah sempat, and it is under You Future platform. Okay, jangan pergi cari dekat Google Classroom. Island pun actually boleh, tapi pergi You Future lah. Okay, and make sure that your internet connection during that time is strong enough. Kalau rasa internet connection is not strong enough, maybe you boleh tunggu malam sikit ke ataupun pagi-pagi tu you start buat untuk you punya test. Alright?
Okay, madam.
Okay, so tak ada soalan dah
Untuk viscosity tak ada, tapi untuk for video punya apa ni guidelines.
Assignment. Okay.
Yes.
Ada yang tanya ada rubric tak for your video assignment? Okay, basically rubric nanti I akan post dekat you all. What will be the rubric for the video assignment, because I need to come out with my own for my classes. Then I will share with you all the rubric for that video assignment. Okay, apa lagi nak tanya pasal video assignment tu?
Tak ada kot.
Tak ada dah?
Tak ada.
Tiba-tiba tak ada. So hantarlah you all punya video assignment tu according to your schedule tu. Nanti I akan buka one of the assignment folder for you to submit your video assignment. Selain video assignment, ada lagi assignment lain tak?
Tak ada. Only for video.
Okay, great. Senang nak mark nanti. Okay, so thank you very much for your cooperation. Thank you very much for your attention. Please study untuk you all punya test esok. This one will cover from chapter 1 to chapter 4 if I'm not mistaken. Baca balik dekat tu, nanti I akan post semula you all punya information relating to your test, and jangan lupa fill up your attendance form. Okay? Kalau tolong pesan dekat kawan, kalau if let's say they are not present during our online session, please fill up the attendance form as well, sebab saya ada letak kolom letak bahagian dekat situ. If the students is not present, what is the reason they don't present? Otherwise nanti I takut I kena bagi warning letter pula dekat you all. Okay?
Okay.
Right. So thank you very much. Thursday ni isi attendance form saja. Okay, thank you. Bye.
Okay, thank you.